Alright, today's topic is about radical expressions, and more specifically talking about square roots and how to simplify square roots and radicals. So, just kind of a reminder with square roots, remember, let's say we have the square root of 4. Remember, the square root of 4 is 2 because 2 multiplied by itself equals 4. Okay, so remember, the square root of something just means what number times a number times itself equals that. Okay, so same thing. 9. The square root of 9 equals 3 because 3 times 3 equals 9. 16. The square root of 16 is 4 because 4 times 4 equals 16. So on and so on, right? 100. The square root of 100 is 10 because 10 times 10 equals 100, right? So that's kind of the idea of what we're working with. It's going to be a lot of this, okay? So knowing your perfect squares, knowing those things will really come in handy when it comes to what we're doing here today. So we talk about squares, perfect squares. Now what happens if you have numbers that are not perfect squares? And that's what we're going to be working on today, is square rooting numbers that are not perfect squares and kind of breaking them down into several parts. So, for example, let's go with 20. The square root of 20. Okay, so we know that 20 is not a perfect square. You cannot square root to get a number, right? Because if you think about it, the next highest ones, closest ones you get is 4 times 4 is 16, and if you go one more, 5 times 5 equals 25. So we know it doesn't work out. It falls in between there, so we can't do that. But what we can do is break it down into two numbers in which they both multiply to 20, and one of those numbers has to be a perfect square. So, I'll show you. So first of all, we need to think of all the numbers that can multiply to 20, okay? So you can write those down if you want. You can say 1 times 20, right? Gets you 20, what else? 2 times 10, right? Gets you 20. 3 doesn't multiply anything. 4, right? 4 times 5 gets you 20, and that's it, right? So these three sets here all multiply to get you 20, which is great. Now, of these three sets of numbers here, which one of those sets has a number in it that can be square root as a perfect square? Well, look right here. 4. This 4 can be square rooted, right? It's a perfect square. So we're going to take these two numbers here, and that's how I like to write it. I like to break it up in like this. Two numbers, the square root of 4 and the square root of 5, okay? So just kind of to reiterate, if two numbers have a radical over it, when you multiply those numbers, you get the number it multiplies to inside a radical. So just a side note here. Alright, a side note. So if I did like the square root of 3 times the square root of 2, that equals the square root of 6. Okay, so we're just multiplying the numbers and keeping the radical with it. The square root of 5 times the square root of 6 equals the square root of 30. Okay, it's the same kind of concept. Okay, so when you break it down like this, always keep your radical with it. It's just, it doesn't change much about it. Just know that two numbers multiplied that have a radical over it also equals that same number multiplied with radical. Okay, so that was our side note. Okay, so two numbers multiplied 20, 4 and 5, right? Now we can go ahead and square root 4, right? We know the square root of 4 is 2, as we talked about earlier. Now 5 you can't square root, which is fine. We don't need it to. So what we do is basically just bring it down as it is. So our final answer is 2 square root 5. Okay, that's the final answer there, and that's it. That's how we do these ones. So we're thinking of two numbers that multiply to our number under the radical, in which one of those numbers is a perfect square. Okay, that's what we want, and the other number has to be the lowest form. Okay, and I'll show you an example of how that works out in a sec. So let's try a different number here. Let's do the square root of 28. So once again, sorry. So once again, we have a number here in which it's not a perfect square. It needs to be square root. So what we'll do is we need to break it up. Okay, two numbers that multiply to 28, and which one of those is a perfect square. So once again, if you want to, you can write down your factors over here. 1 and 28. By the way, this top one you're never going to use for this exercise, but I'm just showing you just to show you. Okay, so 1 times 28, 2 times 14, right? 3 does not factor into it. 4 does. 4 times 7, right? 5 does not, and 6 does not. Okay, so here's our three sets of numbers that multiply to get 28. So now, which one of these sets of numbers, once again, has a number in it that's a perfect square? Well, our good friend 4 here does. So we know that this set here is going to be the numbers we use. So we can write over here. Remember, we're keeping it underneath a radical. Okay. Now, once again, we know that the square root of 4 is 2, and our square root of 7 just kind of stays as it is. That's square root of 7. So our answer is 2 square root 7. Okay, nice. So pretty simple, right? Nothing, it takes a little bit, thinking to get here. Do that. Now, if you get to a number that's pretty big and you're not sure what it can divide into, that's when you bring out your calculator and you just start experimenting. Okay, that's really how it works out. There's really no other way. I wish I could tell you a different way to do it, but there really isn't. Okay. All right. Let's try an example here. It has a little curveball in it, and I'll show you how. 32. So the square root of 32. So we know two numbers need to multiply to get 32. So let's go through our factors again. So 1 and 32. Now 2 can multiply into 16, correct? 3. Can 3 work into it? No. 4. Yes, 4 times 8. And 5, no. 6, no. 7, no, and 8. So once again, these three sets of numbers multiply to get 32. Now, which one has a number in it that's a perfect square? Well, if you look, both of these two sets do, right? Because in this case, we have 16 you can square root to get 4, and 4 you can square root to get 2. So we have two sets that actually work out where one of those is a perfect square. So which one do we have to choose? Well, this is where the other number comes into play, okay? So if you look at 2 here, 2 cannot get any lower, right? You can't square root 2. You can't break 2 up into anything other than 2 and 1. So 2 is done where it is. 8, you can't square root 8, but you can break it down, right? There are numbers that multiply to get 8, right? So for example, let's just show you over here, okay? Let's pick 4 and 8 as our answers, okay? And I'll show you how this works out. So if we did this, we know the square root of 4 is 2, we know that, okay? Now the square root of 8. Now, at this point, in the previous examples, we were not able to break this down anymore, but in this case, you can, into 2 and 4, right? So we're doing more work, okay? So if you can break this number down, your second number, not the one that you square root, but the second number, if you can break it down more than what it already is, then that's not the one you want to use, okay? So we're not going to use this. But I want to show you why, because this second number can also break down. We don't need that. We need it in its simplest form. So that means we're not going to use these ones. We're going to use 2 and 16. Because, as I just said, 16 you can square root to get 4, but square root of 2, you can't break it down anymore. So your answer is 4 square root 2. Okay? So that's how we're going to do this. And that's kind of the trickier ones where you have two sets of numbers that work out. Okay? Always use the one where your second number, the one that's not square rootable, the one that you can't square root, is in its lowest form. Okay? Let's do one more example. Let's do the square root of 125. Okay? So a bigger number, but same thing. Things that multiply to 125, okay? So we'll go over here, 1 and 125 right now. 2, no, you can't multiply 2 to 125. 3, no. 4, no. 5, though. 5 you can. And 5 times 25 gets us 125. Now, it could go higher, but look, we know right here that 25 is a perfect square, right? You can square root 25. And 5 is already in its lowest form. You can't break that down any further. So our answer, we already have our answer right here. The square root of 25, the square root of 5. You can break this down, the square root of 25 gives us 5, and then we bring down our square root of 5 there. Okay, so that one was a little more simple. Now, like I said, if you're having trouble with bigger numbers and trying to figure out what multiplies to get what, okay? Like I said, you can use a calculator, okay? And you can kind of figure it out. So if you don't know what 125 can be, divided into, you can say, okay, you can do 125, start with 2, right? That's our lowest one, 2, decimal, doesn't work. 125 divided by 3, decimal, doesn't work. 125 divided by 4, decimal, doesn't work. 125 divided by 5, 25, okay? So you can use your calculator in this case, if you need to, with these bigger numbers, to figure out the factors of it and which one of them has a perfect square. Okay, so don't be afraid to use a calculator. I don't calculate your shame. It's okay. But that's how you do this here, simplifying radical expressions.